then you will understand. So, okay, let's put it below and whenever somebody joins you, please tell me then. Okay, so dipole is this, right? This is the dipole, right?
Yes, sir.
So how many charges?
2.
2, right? So just imagine the figure. Whenever you have a difficulty in understanding the question, just try to be imaginative, right? So just visualize the diagram, then all the question would be easy. Okay, so now let us draw the diagram for the electric potential. So we have a dipole, okay? We have a dipole. And we are calculating the electric potential at this point, right? Right,
Yes, sir.
Aisha? And this angle is how much? This, right?
Yes, sir.
So let me again extend this. So that, yeah. And let's say this is, okay. So let's say this is R1 and this is R2, right? So the electric potential at this P point would be due to this minus Q charge, right? And this plus Q charge. So due to plus Q charge, it would be KQ by R2, right?
Yes, sir.
And due to this minus Q charge, this would be K minus Q by R1, right?
Yes, sir.
Did I, oh, so this is R1. This is R1, right? For positive, this is R1. For negative, this is R2. This is just a notation. Okay. So this would be how much? KQ by R1 minus KQ by R. Is this clear?
Yes, sir.
Now we have to just simplify this R1 and R2. So just look at this diagram. This is theta. And how much is this distance? Yes. How much is this distance?
A.
A, right? So this is A. And let us draw a perpendicular from this point. So this would be here. So this is a perpendicular, right? So you tell me that if this is A, right? This is theta. So this would be what? Yes. Hello, Mariam. Assalamu alaikum.
Walaikum assalam, sir.
Yeah. So I'm just revising the dipole, electric potential due to dipole. Yes, Aisha, this would be how much? Let us draw this diagram here. So this is the diagram. This is A. This is theta. Okay. So this is, you see that this is base. This is hypotenuse. Okay. Base and hypotenuse. Which trigonometric ratio relates base and hypotenuse?
Cos.
Cos. So cos theta would be base by hypotenuse, right? Cos theta would be base we want to calculate, hypotenuse is A. So x would be how much? A cos theta. Is that clear?
Yes, sir.
So this distance is A cos theta. This is not there. So this is a cos theta. Okay. And let us extend this line and draw a perpendicular here. Okay. Again, this is A. Again, this is A. And this is theta. So this is theta, right?
Yes, sir.
So this would be again how much?
A cos theta.
A cos theta, right? And this distance is R. This total distance is R, right? So from the point and this point where we want to calculate the electric potential. So this point is R. So now you tell me that this distance, right, which is R1, this would be equal to, let's say this is M. So R1 would be nearly equal to PM. Okay. And for the case of this R2, so this R2 would be nearly equal to this, let's say N. Is this part clear to you?
Yes, sir.
Okay, so now we know R1 and R2 and we have to just plug in the value. So PM is how much? This is PM. Total is R. Total is R. This is A cos theta. So this would be how much?
R minus A cos theta.
R minus A cos theta. Right, so this is R minus A cos theta. And this would be how much? This is R and this is A cos theta. So this total would be.
R plus A cos theta.
Now we just plug in these values, right? So this would be VP would be KQ R minus A cos theta and minus KQ R plus A cos theta. Okay, so we just plug in the values. This is, we take the LCM, this become A minus B, A plus B. A minus B, A plus B is how much? Yes, Aisha.
Could you repeat?
Yeah, A minus B and A plus B. How much?
B square minus.
Yeah, A square minus B square, right? So R square minus A square cos square theta. And this is divided. So this becomes R plus A cos theta and minus of this divides and this become R minus A cos theta. So your this is R minus A square cos square theta, and this is R plus A cos theta minus R plus A cos theta. So R cancel, right? And we have 2A cos theta. So KQ2A cos theta divided by R minus A square cos square theta. So when now the further part is the simplification, right? So this you already know. So should we skip this?
Yes,
So, yeah, so this is Q2A, which is P. So KP cos theta by R square. This is what we got in the previous class, right?
yes, sir.
Yeah, so is this clear to you, Aisha and Mariam? Is this clear to you? Okay, so let's get back and yeah, where are the rest of the people who has not come? So Saad and Hasib has not come yet. So let's do the question that we were doing. Yes, Mariam, you didn't appear for the fortnightly test. What happened?
Sorry, sir, I couldn't hear you.
Yeah, there was a test on Friday, right? So you didn't appear for that test. Please, take those tests. So those are for your practice. So please be in those tests. Okay. Where was that question? So this was the question, right? This was the question, and okay. So let's do this question, and in the meanwhile, they will join. But I have to do 3 topics today. I have, so let's quickly complete this question. Let me see if I can complete this question. Yes, I can complete this question. Hmm? Okay, so in here I can please. Okay, this is not copy. Hmm. So now you guys will help me in solving this question. We want to calculate the electric potential at this E point. Right, guys? This was the question. Right, this was the question, right?
Yes, sir.
Yeah, and okay, so let's name it with different colors. So then this would be, so this is A, this is B, C, D. Okay. Now VE would be, so how many charges do we have, Mariam? How many charges do we have, Mariam?
Yes, sir.
Yes, how many charges do we have?
4.
Yes, absolutely right. So why were you hesitating? So we have 4 charges, right? So the potential would be due to all those 4 charges. So we have to follow the potential due to n number of charges. So that will follow the vector sum or the algebraic sum. Aisha.
Sir, could you repeat?
Yeah, so there are 4 charges, right? So we have to apply the potential due to multiple charges, n number of charges. So that is vector sum or algebraic sum.
Vector sum.
Potential.
Oh, algebraic.
Algebraic, right? So this would be simply VA plus VB plus VC plus VD, right? Because this is there would be no I, J, K. We don't need to bother about the directions. So this is the simple algebraic sum. Now let us calculate what is VA. Okay, so VA, and let's name it as VAE. Okay, so VAE, we are calculating the potential at this E point. So this would be K, Q by how much? This AE distance, right, guys? So first,
Yes.
first let us calculate this AE somewhere. So this is A by 2. This is A. So this is the hypotenuse, right? So this would be A square plus A square by 4. Who left? Oh, Mariam got disconnected. So this would be how much? This would be 4a square plus a square, 5a square by 4. 5a square by 4, which means root 5a by 2. Is that clear?
Yes.
So this would be simply AE, right? KQ by AE. So K is K, Q is E, and AE is root 5A and 2 goes in the. So this is 2KE by root 5. Yes, Mariam. So to calculate AE, we will just use the Pythagoras theorem, right? So this will come out to be root 5A by 2. Okay, what would be VB? Right, so VBE is K and Q by BE. Right.
Yes.
So this would be simply K and this is Q is 2E. And again, this is A by 2. So A by 2, so this goes over here. So 4KE by A. Right. And now EC. So VCE. Okay, this would be how much? So this is again KQ by, this is again how much? This distance?
A by
Yeah,
2.
A by 2. Right, so this is A by 2, this is CE. So K into minus E by, this is A by 2. So minus 2KE by A. And then last, VDE. So this is KQ by how much? DE. So this is K and Q is minus 2E by this DE is the same distance. A by 2, A, so same distance. Right, root 5A by 2. So this is how much? Minus 4KE by root 5A. Okay, so is this part is clear, right, guys?
Yes,
So
sir.
now we have to just add them. So VE would be simply 2KE by root 5A plus 4KE by A plus minus 2KE by A and minus 4KE by root 5. Right. So this is 2KE by root 5. This is minus. So this is minus 2KE by root 5. And then 4KE by A minus 2KE by A. So 2KE by A. Right. So let us take 2KE by A common. So this is 1 minus 1 by root 5. So this is the answer. Is that clear, guys? Yes. Aisha and Mariam. Clear?
Yes, sir.
Okay, you guys quickly note it down and then we will go ahead. Yeah, whenever you guys have noted, please tell.
Yes, sir. Done.
Done. Mariam,
No, sir.
no, sir, or yes? No, did you say no?
I'm not finished, sir.
Oh, okay, okay. Please note it down. Okay, so Hasib has just. Hello, Hasib. Assalamu alaikum. Yes, Hasib. Assalamu alaikum.
Walaikum assalam warahmatullahi wabarakatuh.
So you are so early, Hasib. What happened?
I'm sorry, sir.
Yeah.
I just came to India, so I just.
Oh. Oh, okay, okay, okay. Don't worry about that. Okay, okay. Yes, so please take the screenshot of this question. This was the homework, right, Hasib? So this
Yes, sir.
question was the homework, and I guess you were traveling, so you couldn't do this. So please,
Yes.
yeah, please take the screenshot and yeah. The question was that we have to calculate the potential at this E point, right? And we have 4 charges, Hasib. So the potential would be just the algebraic sum of all the 4 charges, right?
Yes, sir.
So we just calculate the potential due to individual charges and then just add them. So this is the answer that we get. So please take the screenshot and then we will go ahead. Okay. Yeah, taken.
Yes, sir. Done long ago.
Okay. Mariam, did you noted it down?
Yes, sir.
Okay, so let us go ahead and yeah, so the next topic is, I was doing this electric dipole, but before I do that, let's note this point that work done in bringing or in moving a charge from, let's say, point A, whose potential is VA, to point B, whose potential is VB. So this would be simply, work done would be simply a charge Q. So this would be simply Q VB minus VB. And let us also write this in the subscript notation. So VAB. Just remember this. Okay. Yes. So is that clear, guys?
Yes, sir.
Okay. So just note down the same problem. Just note down the same problem and you guys please do this homework. So we have this E point, right? And this O point. And we have the same charges, E to E minus E and minus 2E. So this is O point. So we want to calculate what would be the work done in bringing or in moving a proton. So let's say there is a proton here, right? And we want to move this proton from O to point E, from here to here. So simply saying that we want to calculate what is the work done in bringing the proton from O to E. Right. So what would be that? You guys, can you guys tell me? Hasib, you tell me.
Yes, sir.
Yeah. So what would be the work done in bringing this charge or moving this charge, this proton P from O to E?
So Q,
Yes, absolutely right.
it will be V O
So you see,
V
whatever,
E
yes, yes,
minus
VE,
V.
yeah. So we calculate what we do in this question. So the question is that we have to calculate VOE. This is the question. And also calculate, let's say, work done by the electric field. So V electric field. So you guys know that this would be simply minus of VOE. So you guys take this as your homework. Is that clear?
Yes.
Because you know how to calculate VE, right? You guys know how to calculate VO. So calculate VO, calculate VE, you already know. So you only need to calculate VO and then just plug in the charge of the proton. So is that is the question clear to you guys?
Yes, sir.
Yes, Mariam and Aisha, clear?
Yes, sir.
Yeah, please. So please do this homework. Okay, so now let us move ahead. So in the previous class, we finished up to this point that we have a dipole, right? Whose charge is minus Q and plus Q. And then we have this point and we are calculating the potential at this point. So let's say this is P and the angle is theta, right? So what we found out that the potential was Kp, and what is the rest, Hasib? Do you remember?
No, sir. Can you remind me again?
Yeah. So the potential of this dipole at this P point was we derived this Kp cos theta by r square, right? So now you guys remember.
Yes, sir. This is the formula.
Yeah. So just remember this derivation. We derived, yeah, this one, right? So this we derived in the previous class. So from this point we derived. Okay, so you guys keep revising, otherwise you guys will forget because I also tend to forget whatever I've learned. So please, you guys revise and revise again and again, repeat. Okay, so this is the potential at this point P. So we have two cases, right? We have two cases that we have this dipole and there are 2 points. So this is 1 point and this is the other one. Let's say this is P1, P2. Okay, so Mariam, you tell me this is what point? Yes,
Sir,
Mariam.
can you repeat?
Yeah, so we have this dipole. Okay, we have this dipole and you tell me that we are on this line. So what is this point? Forgotten. So yes, this we learned in the electric charges and field. So we have repeated this so many times.
So equatorial.
No, you are thinking in the right direction, but the answer is the. So this is the line on the same line which is on which this dipole is in, right? So this is the axial point, right?
Yes, axial.
Right, and this is the equatorial. Okay, Mariam, remember now. Yes. So keep revising, you guys. Otherwise, you guys will forget. Whatever you have learned, you guys will forget. So please revise again. Make the notes, short notes, right? Make the short notes and just look at them. Okay, so this is the axial point. So Aisha, you tell me that what would be theta for the axial point? Yes. What would be theta for the axial point?
Sine theta.
No, just I'm asking that how much is the angle? Theta is this, and you are on this axial point, right? So this is the dipole moment direction, and this is the angle. But this point is shifted to this point. So this is here. This P is dropped down, and this is here. So now you tell me what is the angle between this dipole moment and this point. Well, how much is this theta?
I didn't get you.
So you didn't get the question. Okay. So you have this line and this is theta. But you drop down this ray and you take it here. So you have this line and you have this line. Mariam, yes. So the lines are the same, but the angle is totally opposite, Maria. Okay.
Axial point is
Yeah.
180.
180. So Mariam and Hasi, both your answer is 180. So this is the point, right? I have taken this point to here. So this is the point and this is the line. So how much is the angle?
0 degree.
0 degree, right? Theta is 0. So if I have taken this point in here, right, then this theta would be, this is theta, this is theta, then this theta would be how much?
180.
180. But I am on this line in here, right? So theta would be 0 degree. Okay. So if my theta is 0, so V axial would be how much? Cos theta is 0, cos 0 is 1. So this is Kp by R square. Right. Remember that what is R? So this is R. This is R. So this is R. Right. Let me erase these diagrams. Okay. So Kp by R square. Is that clear, guys?
Yes, sir.
Okay. And the second case. So case second. I have the equatorial point. So you guys don't fumble this time. What is the angle? Theta is how much?
90.
90.
90 degree. Okay. Yes, absolutely right, guys. Yes, Mariam, you are also correct. So this theta is 90. So what would be cos 90?
1.
So what is sine 90? If cos 90 is 1. Yes.
0.
Yeah, this is 0, right? Cos 90 is 0. Right, guys?
Yes.
Yes, sir.
So cos 90 is 0, this part is 0, so the whole part cancels out and we have V equatorial as 0. So these are the two special cases. You guys just note it down and then we will do one question based on the dipole. Okay. Yeah, you guys quickly note it down. So I want to do, yeah, I want to do electric field and electric potential relation and then potential energy. So I want to reach there. So whenever you guys have noted down, please tell. Yes. Yes, Hasib and Aisha finished.
Yes, sir, done.
Aisha done.
Yes, sir. Done.
Okay, so now let us do one question and let us try to understand. So we have, this three coordinate system, right? So this is y, x, and z, and we have a charge. So two charges are placed at let's say A, which is 0, 0, minus A, and B. Let's say this is not A, this is P. Okay, and Q, which is 0, 0, A. So this is two charges, and this at P charges we have minus Q charge, and at Q we have Q charge. Okay. So we have this diagram. So 0, 0, minus A. So the third coordinate is which axis, guys?
Z.
Z axis, right? So third our coordinate is Z axis, and 0, 0, minus A. So we have this XY plane, right? We have this screen which is XY plane. So this length is X, this breadth is Y, right? So the direction which is coming out of that screen, so that is the Z axis, right? And the direction which is going into that screen, so that is which axis? Yes. Yes, who one of you guys said some answer. So yeah, the no. The direction which is going inside that screen. So screen is XY. Outward is Z, inward is what? Okay, so let me ask this question. Yes, Mariam, you are right. So this is X, right is X, so left would be what?
Minus X.
Minus X. So outward is Z, so inward would be what?
Minus X.
Right. So this 0, 0, minus A will lie in the inward, right? So this would be in here. So let's say this is P point, which is 0, 0, minus A. Okay. And then we have this Q point, which is 0, 0, A, right? And the distance between them would be how much? So let's say that This is charge Q, and this is charge how much? This
Minus.
is minus Q. Okay, so this distance is how much? This is A, this is again A. So 2A, right?
2A.
Yes, yes, madam. So this is 2A. Okay. Now we have three place. So we have 3 points. So calculate, we have 3 points. Let's say A is 0, 0, Z. B is A 0, 0. And C is 0, A 0. Okay. So first question is that calculate VA, VB, and VC. This is the first question. Second question is that what is the work done in moving an electron from A to B? Okay. And the third question is that calculate the work done by electric field from A to B. So these are the 3 questions. Okay, so first you guys tell me that this system is what? Yes. So this system is what? Electric dipole, right? This is an electric dipole. Yeah, and this A point. So we have to calculate first the potential at A point. So we have to first calculate VA. Okay. So you guys tell me that A is the axial point, equatorial point. Which point is A? Yes. So which point is A, guys? Mariam is saying axial point. So do you guys agree with Mariam answer? So this is A point, which is 0, 0, Z. And B is A 0, 0. Okay, so but let us focus on this A point. So this is axial point or the equatorial point? Mariam is saying axial point. Hasib,
So, axial point.
axial point. And Aisha,
Axial point.
axial point, right? Because we have this dipole, and on the same line, we are calculating the potential. So this is the axial point. And we know that for axial point, the electric field is simply how much? Kp by x square, which is z square, right? So, and what is, how much is Kp? P is how much?
P is equal to 2AQ.
2aq, right? So 2aq by z square. So 2 kaq by z square. This is Va. And Aisha, you tell me first that this A00 will lie on which axis?
Exact.
X axis, right? So A00 is somewhere here. This is point P. Okay. And Hasib, 0A0 on which axis?
Y-axis.
Y-axis. So somewhere here. 0, this is C point, 0A0. Okay. So now you guys tell me that this B point is axial or equatorial. We have this electric dipole. So this is Z axis. So you guys tell me X axis is at what angle with the Z axis? Yeah,
0, sir.
X and Y 0 degree. So this is X, Y, Z. X, Y, and Z.
Yes.
Or you can look at your room. So just look at the corner of your room, the floor, the length of the floor is X, the breadth is Y, and height is Z. So yeah, yes, Mariam, you are right. So yes, so length is X in one corner, floor is XY plane, right? Floor is XY plane, the length of the floor is X, the breadth of the floor is Y, and the height is Z. So the dipole is on the Z axis, right? And the point is here on the X axis. So that would be at what angle? Yes, I see. Didn't get the question. Yes,
So it would be 0, no?
0. So if I ask you that, what is the angle between the Z axis and the Z axis? So that would be 0.
0. Okay.
But what is the angle between this is X axis? This is
Yes.
X, this is Y, and this is Z. So what is the angle between this X and this Z?
X and Z, it's 180.
This is X, this is Z. So
Yeah.
just make your finger like this
Yeah,
and
90.
90 degree, right? This
Yes.
one and this one. So 90 degree, right? So the angle is 90. So what point? Equatorial or axial?
Equatorial.
So equatorial, so that would be 0. VB is 0, right? And Aisha, for this C point, axial or equatorial?
So equatorial only.
Okay, yes. So this was question for Aisha. Yes, again a 0. Is that clear, guys? Yes, is this clear?
Yes, sir.
Okay, so now we have calculated all the potentials, and in the second part, they want us to calculate what is the work done in moving a proton from A to B. So not a proton, but electron. So this would be Q. And Aisha, what would be here? Yes,
VB minus VA.
VB minus VA. So Q is how much? This is, remember, this is an electron. So Q is how much? Yes.
The
So,
error.
Yeah, Q is simply minus E, right?
yes, minus E.
And VB is 0 and VA is 2KAQ by Z square. So minus minus becomes plus, and this is 2EKAQ by Z. So this is the answer, right? And if you want to calculate the work done by electric field, so that would be simply minus of WAB. So this would be simply minus of 2EKAQ by Z square. You guys quickly note this question, and then we will do the next part. What is that? Yes, any doubt in this question, guys?
No, sir. Yeah, whenever you guys need me to scroll down the screen. So yeah. Okay, this part. Yeah, whenever you guys have finished noting, please tell. Yes, done, guys. And after this class, you guys have a class assessment. So please log into your account and take that test, because I will have another class, so I won't be able to join you. You guys, please log into your account and take that test.
Finish them.
Finished.
Done,
Aisha
sir.
and Aisha, done.
Done, sir.
Okay, so the next topic is electric field as gradient of potential. So, but let me talk about. Okay, but let us talk about this and this one. So now up to this point, we have calculated the work done due to single charge, multiple charges, and due to dipole. But what is the work done in external electric field? So you guys already know that if we have electric field, right? So this diagram you guys are familiar. So let's say you have this electric field, right? And you have this charge Q. So what would be the electric force? Force would be QE in this direction. Right, guys?
Yes.
Yes, sir.
So the external force that we would apply would be this F external. Right. So this W would be how much? This would be, let's say that there can be two forces, right? One would be that this F is, or this E is uniform. Right. So we have two kinds of work. One is that F dot S, and the other one is this integral of F dot dx, right, or dr. So these kind of, for this uniform force or the constant for force, this is we use this, and for the variable force, we use this, right, guys? Is
Yes.
that
Yes.
yeah? So W would be how much? W would be, let's say we have uniform electric field, so F external would be how much? This would be minus of QE, right? Because F is QE. So F external is minus of F, right? Electric field. So this would be minus QE. So work done in the uniform electric field would be how much? This would be simply minus of, or let's say F external
External.
dot dr, and this would be minus Q E dot dr. Okay, this is let's say W. And if I write this as this one, so WAB. Okay, this would be simply minus of QE dot RB, or let's say RA minus RB. Just remember this. Okay, or you can write it in this way. So final initial, right? So final point, you are bringing some charge. This charge, this is the final point and this is the initial point. So this would be simply minus Q and E dot R final minus R initial. Is that clear, guys?
Yes, sir.
So you guys already know that this is how much? This is VB minus VA, right? This is Q VB minus VA. So this would be minus of QE dot RA minus RB, right? So Q cancels, and VB minus VA would be simply minus of E dot RA minus RB. Is that clear, guys?
Sir, minus won't get cancelled.
Which minus?
Minus Q.
Yeah, QQ gets cancelled, right? Minus would be there.
Okay.
Yeah, because this is multiplication, so why? Yeah, so this is the relation between work done and electric field, and this is the relation between potential and the electric field. Okay.
Yes, sir.
And I can write it in the integral form like this. So if I write it in the integral form, this would be, you guys first note it down. So this was due to uniform electric field. Okay. Yes, Mariam and Aisha, any doubt?
No.
No, sir.
Yes, did you guys note it down?
Yes, sir.
Okay. Mariam and Hasib, did you guys note it down?
Yes.
Finished, sir.
Finished. Okay. Oh, there should be. So A to B would be RBA. Yeah, I guess this is correct. Okay, so let's do one question based on this, and then we would understand about the next topic. So let's say that I have what is the work done in moving a charge from, let's say, moving a charge of let's say 2 coulomb or microcoulomb in the presence of electric field which is 3I, and what is the Newton per coulomb, right? So 3, if I write 3I, this is uniform, or this is this changing? Yes, is this uniform or is this changing?
Sir, changing.
If I write E as 3x square I, so is this uniform or is this changing? So this is a uniform and this is changing, right?
Okay, sir, I get.
Okay, but let me check I guess there is so this would be RB minus RA. Let me check that. I guess yeah. So this is RB minus R. Yes. So this would be RB and this would be RA. Please correct that. Okay, RB minus RA. So this is we can write this as work initial to final. So this is the initial point and this is the final point. This is equal to final point minus initial point. Please correct this, guys. Sorry about that. So please correct this. So then this would be VA minus VB, or this is RB minus RB. Okay. So RB minus RB. Please correct this, guys. Did you guys correct this part?
Yes.
Yes. Yeah. So just remember this, that whenever we calculate, work done in moving a charge, let's say this initial point from final point. So this would be simply minus of QE dot and R final minus R initial. Just remember this. So in this way, you guys can remember, right? So that is why I got confused that why I am getting this one. Yeah. So this would be the case. Is that clear, guys?
Yes.
Okay. So now, so this is my electric field. Is this uniform or is this varying? Yes. Is this uniform or is this varying?
So uniform.
Uniform, right? So now we want to calculate what is the work done in moving a charge 2 microcoulomb in the presence of this electric field from point A, which is 1, 2, 3, to point B, which is, let's say, 3, 4, 5. Okay. So you guys tell me that first you guys tell me that we want to calculate WAB. Right. This is what we want to calculate, right, guys?
Yes.
So this would be simply minus of QE, right? Dot what? RA or RB? Yes,
RB
RB, right? RB minus RB.
minus R.
Okay, so Aisha will tell me what is RB. Yes, Aisha, tell me what is RB. Yes, vector class, vector part. So what is the coordinate of B, Aisha? No, what is the coordinate of B? So this is the coordinate of B, right? So RB would be simply how much? Position vector, RB would be how much? Yes, 3, 4, 5 is the coordinate. So RB would be how much? You guys have forgotten. So,
3 I cap 4 J.
right. And RA would be how much?
1 I cap, 2 J cap, 3 U cap.
Right. This is K, not U. Okay. So this would be RB and RB and RA, right? So let us plug in these values, and Q is how much? Q is 2 microcoulomb, right? Micro is minus 6. Yes, I plus 2. No, you have 2J plus 3K, Maria, right? Okay, and E is 3I dot. So 3I. And this time you guys be, yeah, so don't do any mistake, right? So minus of I 2J minus 3K. So this is minus of 2 into 10 to the power minus 6. 3I dot, this is 3 minus, so 2I, and 4J, so 2J, and this is 2K. So 3i dot this, what would be, what term will survive? So what is this value? Yes, what is this value, guys?
So, 3 into 2, 3 into
Yeah, 3 into 2. And will there be any term, any more term?
there will be no term.
No term, right? Because I dot I only will survive, and I
Yeah.
dot j would be 0, I dot k would be 0.
Yeah.
So minus 2 into 3 into 2 is 6. So minus 12 into 10 to the power minus 6 joules, which is minus 1.2 into 10 to the power minus 5 joules. So this is work done from A to B. Right, guys?
Yes, sir.
Yeah, so you guys quickly note it down, and then in the 15-minute I will. Okay, so this is about the uniform electric field. Okay, just remember that this is about the uniform electric field. For non-uniform, the work done would be in the integral form. Yeah, noted, everybody. So whenever you guys have finished noting, please tell me.
Done, sir.
Yes, Aisha and Maya. Yes, Aisha, done. Okay, now you have the variable field. So for the variable field, the work done from 1 to 2 would be for the variable field. So work done would be simply minus QE dot dr from 1 to 2. Okay. So this is the from infinity to point R. Okay, so you guys already know this, that if we have if we are calculating the work done in bringing a charge from infinity to point P, so this is this would be QE dot dr, right? And this is infinity, and this is point P. This part you guys knew, right?
Yes.
So we can write W12 as delta V, right? Or we can write this as, so this is delta V, which is equal to minus of Q E dot dr and 1, 2. So we can write this as, or we can write, so this is the potential, right? V. If I divide it by Q, not this one. So if I divide W12 and Q, if I take Q in this place, so W12 by Q, right? So this would be how much? W1 by 2, W12 by Q, this is how much? Just take the analogy from here. If I take this Q, so this is how much, guys? This is what? This was the first class.
Yes, I got it.
Yeah. So this is potential, right?
Yeah, the potential.
Work done in bringing a charge from infinity to point P, right? So
Yes.
this is V, which is minus of infinity to P point, right? This is E dot dr. Okay. So this is called the potential, right? And this potential is related with this electric field E. But if I write this, so if I bring a charge Q from 1 to 2 point, right? So this would be called the potential difference, V2 minus V1, which is delta V, right? This is minus of 2, 1 E dot dr. Okay. So if I bring the charge from infinity to point P, this is called potential. And if I bring the charge from point 1 to 2, so this is called what? Is that clear, guys?
Yes.
Okay, so this is the integral, right? This potential is related with this electric field integral. So if I revert this back, right? If I take this integral in the other side, so this will change into what? So if I write E, okay, and take the integral in the other side, so this would be how much? This integral will change to what?
Dr.
Yeah, this integral will change to differentiation, right? So
That's it.
dr goes in the denominator, and this is dv. So minus of dv by dr. Yeah, differentiation. Absolutely right. So this is how this electric field is related with potential. So we can we say this as the electric field as the gradient of potential. Why we are saying that is why we are saying this as gradient? Yeah. Do you guys remember, or can you guys can you guys tell me that why we are calling it as the gradient? Yes. You guys please note it down first, and then just think about the answer. Okay, you guys please quickly note it down.
So because negative gradient.
No. I'm asking about negative sign. I will tell you about the negative sign. But you guys tell me that. So first, did you guys note it down? This one.
No, sir, we have to write.
Yeah, please note it down. So this I did from the analogy. This part you guys already did. So from the analogy, this part was done. Yeah, you guys, I wanted to start this potential energy, but I will not get any time. So
Done. Sir.
done. Aisha and Mariam, done. Yeah, noted everybody.
One minute. Done.
Okay, so I have 2 minutes more, but okay. So the electric field is minus dV by dr. Okay, so let's say that what is the meaning of this sign and what is the meaning of this part? Okay, dV is that your potential is changing, right?
Yes.
So yeah, so first you guys tell me that, let's say I have this dx by, let's say this is speed. So I write it as dx by dt. So this is called what? Yeah. So if I take the differentiation with respect to time, so that is called that.
Dx by dt.
Yeah. So that change is called something. Yes. So if I take the change with respect to time, that is called
Acceleration.
right. So rate of change of position or distance. Right. So whenever we take the change with respect to time, so that is called rate. And whenever we take the change with respect to position, so this is called the gradient. Is that understood? Yeah. So if I write dv by dx, right? So minus of, let's say, so this is called what? This is called the gradient. Is that clear, guys?
Yes, sir.
Okay, so
And
today's
what
class,
does the minus indicate?
yeah, the minus sign represents that the direction of the electric field Direction of electric field will be from high potential to low potential. Okay, who has come? Oh, Rifa has come. Okay, guys. So what should I do? So you guys log into your account and you will find some active test. Okay. And the test will be on this electric field as the gradient of potential. So E is equals to minus dV by dr. And just I will give you guys some hint. I will do the question in the next class. So Ex would be minus dV by dx, Ey would be minus dV by dy, Ez would be minus dV by dz. So yeah, please take that class assessment test. Okay, guys.
Sure. Sir.
Yeah, bye guys. So I will repeat this part again in the next class. So on Thursday, I will repeat some portions because I think that you guys, yeah. So we are just calculating or we are just studying the effect of the external electric field. So in the previous class, we learned about that we had some charge, right? And due to point charge, due to multiple charge, and due to dipole, we calculated the potential. But now we are calculating the potential in the presence of the electric field. We don't have any charge. We are calculating the electric potential in the presence of the electric field. So this was about this class. So bye guys. See you on Thursday. Okay, guys.
Thank you, sir.
Bye. Bye, guys. Bye.
Enjoy your day.
Yeah, thank you. Thank you, Asi.